So this is the Structures 1 project, the testing and analysis of the spaghetti bridge by Joseph Boy and Stevo Bozic. So basically, the main purpose of this project was to construct, analyze and test two bridges made from spaghetti. The requirements were that the minimum length for the bridge must be under 350 millimeters long, and that the weight should not exceed 200 grams. Additionally, with the design and construction of the spaghetti bridges, it is important to keep into consideration that the spaghetti itself has a low compressive strength, creating the need to keep members in compression to a minimum and as short as possible. With this, the group had to make sure to do further research into the many different types and designs of bridges. Basically, this assessment piece had required the groups to construct a bridge and testing it to failure in order to design and construct the second bridge to be better in the weight to load ratio. So the materials used were super glue, scissors, spaghetti, an electronic scale, a ruler and a marker. Before commencing with the building, the test bridge itself, the group had made sure to do extensive research about the different types of bridges beforehand. This was so that there would be a better understanding of the designs and the purpose of the different designs of the bridges itself. So with the design of this bridge that we did for the test bridge, we just did a very basic and simple design. We just tried to keep it as simple as possible and make it as light and as strong as we could. With this, we kept into consideration that the aim was to keep the bridge light and the overall structural integrity of the bridge to still be as strong as possible, even though the weight of the bridge may have been quite light. But then, due to the inexperience of the group members and the group itself, due to this being our first bridge and not the second bridge, there were some mistakes that we would have made during this process. So here in the photos you see are the top and the side view of the bridge. So furthermore, the group started off by simply making the two sides of the bridge, keeping in mind that both sides had to be as identical to each other as possible. The two sides of the bridge were about approximately 400 millimeters long. After constructing both sides of the bridge, the group went on to building the top and bottom of the bridge. After this, it was carefully placed and glued together, with all components being put together. At the same time, we were very cautious and tried to make as least movement as possible so that the glue would set dry and much quicker. After this, we added additional bracing across the trusses to ensure a more sturdy and aesthetic stance and build. So in the end, overall, we were able to make the bridge weigh only approximately 62 grams, which is very light. But then we were also unsure if it would be able to take much weight due to how light and the minimal amount of spaghetti that was used throughout. So this is the video of the bridge being tested. So after the testing of the bridge, even though we're playing this right now, I'd like to talk over this. So after the testing of the bridge, there were many things that had come to our surprise and attention that we were unsure or never thought of before testing it. This, though, ultimately really did help us with the second design of the bridge. So what we had noticed that we have not noticed before was that because we built the bridge so light and it wasn't the most sturdiest bridge, it kind of started to give way at times and wasn't able to carry as much weight as we thought. We also thought that most of the weight being stressed onto the bridge would go towards the bottom beams of the bridge, hence why most of the other beams apart from the bottom of the bridge were very thin. Though the bottom beam of the bridge was a little more thicker, it was only able to hold so much weight before failing. This was also due to the bracing of other beams not being thick enough to take on more of the stress generated from the weight being pulled on the bridge. Hence, it is evident that making this bridge had made us more aware of what we could have done better and what we did do good. So listed here are just some of the improvements that we could make and some of the things that we learned. So being able to make this test bridge overall really did help us realize on what we did wrong and what we could have taken into consideration and improve on for the next bridge. From the test bridge, we were able to see that because it was so light and there weren't enough materials, like I said before, it started to give way very early on in the testing stages. We also learnt that we should have let the glue stick and dry more, given it more time to dry and stick during the processes of making it, because we started to tend to be impatient and rush at times because we were scared of the deadline and not making it in time. But it's always better to make sure that you do it right than having to go back and redo it yourself. So this is the second bridge that we're up to now. So similarly to the test bridge, the processes in which the group underwent with constructing the bridge was very much the same. We kind of went through the same process and the design of it was very similar. So this is the Warren Truss Bridge as well, that kind of design. With this second bridge, the group had decided to go with that design, and the reason as to why we continue with this design is because we had already built the test bridge prior with this same kind of similar concept and design. So as we have gained more knowledge and experience from it, it was better that we kept on proceeding with what we knew best. This ultimately saved us a lot of time because we didn't have to do as much researching and were able to get stuck into the designing and constructing of the bridge straight away. Similarly, we started off by quickly designing the bridge and labeling it where we could. The bridge was overall approximately 42 centimeters long, just from here to here. So this is the bottom and this is the top. So this is the trusses that we built through. So learning from the test bridge, we kept into consideration that the beams were to be made much stronger and thicker. Though we knew it would add on much more weight, it was a gamble that we were willing to make. As we knew that what we were doing would ultimately either make or break us, it was simply a part of the learning experience. So we went to make on the two sides. The two sides of the bridge were made where the bottom beam consisted of around 20 spaghetti strands, and the top consisted of 10 spaghetti strands. We had to make sure that the columns and trusses were longer but stayed at 3 strands, just like the previous. But this time we had decided that with this bridge we opted to add a double truss design. So here we had a double truss design just to make sure that the bridge was much stronger than the previous, where there was only a single truss design. We also added 9 beams in between the bridge to connect them, so we got 9 beams right here, if you can see. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That was very good. The bracing itself was well glued together, as well as the bridge itself. The group kept in mind to properly glue each spaghetti sticks and strands throughout to ensure that there were more specifically weaker points and unglued gaps that were all filled up, so we wouldn't have any problems with any of those. Overall, the bridge ended up weighing 217 grams, so that was not too bad. So this is the top and the bottom view. So this is the bottom view right here with all the cross sections and the bracings, and we've got the top view. So we've got some more photos here as well. It just shows that this bridge is much more sturdy and much more reinforced than the previous bridge, which it's helped us a lot. So here's the video. As evident in the video where the second bridge was tested, it held very well. The reason for this is because of the further reinforced beams and bracing being added and strengthened throughout. In the end, the bridge was able to take up to 14.5 kilograms, to which we were very happy with as a group. Also, the bridge had only failed within one small area, and that the rest of the bridge did not even break, crack, or even move at all. So the only piece within the bridge that gave way, which made us fail at 14.5, was in the middle. That was where the steel plate would sit. So in one of the two sides that held the the steel plate, one of the sides failed, and that was what caused us to basically stop at 14.5 kilograms. Furthermore, from doing this, we learned that the bridge was much sturdier and significantly stronger than and with more reinforced cross bracing and thicker beams. It's important to let the spaghetti sticks dry properly before moving on to further processes. And most important of all, we had learnt that the design and construction of our bridge was very strong, as it did not even budge slightly, and that if we had known to make sure the middle component of the bridge supporting the steel plate was more well reinforced, then the results would have been much more impressive. Last but not least, we've got just the future recommendations. So for the future recommendations, for anyone who may be part of undergoing this project in the future, we recommend that they have to have something that they strive or aim for. So just set out what they want. To not build the bridge last minute, and to give yourself as much time as possible so you don't have to rush the processes, and make sure the quality is there. And to make sure that the groups are to read the criteria well before commencing the construction of the bridge, as many groups have forgotten to read the criteria properly and have done mistakes where the bridge was not long enough, wide enough, or simply it wasn't within the range of the weight requirements. Thank you very much for listening.